All right. I think everything is working fine. I have to say, I think, because some of it looks like it's not. All right, there we go. There we go. All right. All right, why don't we go ahead and start? All right, I'm back. Oh, something's wrong with my avatar. Oh, I wonder what's wrong. He's just continually talking. All right. See, I knew something was not working. There's always something. All right, okay. All right, 1 second. Let's head over. Let me see about what's wrong with my avatar. Hey, the code guy. How's it going? I'm busy trying the air. Okay, there we go. Oh, I see what's going on. Okay, fix it. There we go. Yeah, fixed. All right, all right. Yeah, there was something. The levels were a bit off. I don't know why. I wonder how that happened. Either way, let's go ahead and continue programming. Yesterday evening, I was able to find a bit of time to figure this thing out, and I figured out a couple things that were causing some of the issues. So the first on the list here is that I had a double slash here for the division. Apparently, I just need to have it be single because a double slash will change the way things work in Python. So 9 divided by 5, you'll get a decimal. 9 divided by 5 with a double slash, you get a rounded integer. Which, yeah, that's... yeah, that was throwing an awful lot of my stuff into a massive loop. Actually, I believe that this should be... It's more of a... Yeah, this pretty much tells you how many times it can go into a... It tells you how many times this can go into it. So this would be 3, then this would be 4. So, yeah, it tells you... Oh, having fun programming. Figuring things out. Remembering the most basics because sometimes you forget things when you don't use them so frequently. Actually, I should probably put over here and tell it to organize the code a bit. There we go. All right. Yeah, it's quite there's an awful lot of people out there. They tend to forget that the brain is like a muscle. I mean, of course it's not a muscle. The brain is a big blob of neurons, but when you want to do something like be an athlete, you have to constantly be training your body and performing the same actions and over in order to perfect the skill. And the same thing goes with thinking. Most people would think that you wouldn't need to do that. You just need, you read it once and you'll be done. But no, you actually need to train your brain to be able to hold information and be able to recite it or pull it back out. So if a lot like wanting to be the best at, I don't know, boxing, you definitely need to learn the stances and drill it into you what the stance and the punch technique is. Same thing is when it comes to doing anything else that involves your brain. So, all right. So yeah, there was that first issue right there. Doing that immediately solved half of our problems. And then the second one was right here, where I just needed to invert the pretty much how the things are sorted. I need to go through and see if it will work, because it works great with the frames. Yeah, it works great with the frames, but I don't know about the layers. So I need to quickly do a layer, test the code with the layers to see if that works. So here we'll have layer importer. And then ideally, if I run all of this, layer importer is not defined. Oh yeah, okay. I'm guessing I just import, yeah, here it is. I just import framer. So let's go ahead and import layer now. There we go. We should get an image up in a second. There it is. And it's all jarbled mess. Okay, yeah, we definitely have to fix that. Yeah, that's definitely an issue. So yeah, this is one reason why. This is actually one reason why I love playing puzzle games, and I love doing a lot of these mental gymnastic style games. Let's see here. Actually, I can already list a couple of games. They really need to re-release them. Come on, level 5. These games they don't need to languish on their old. Yeah, I'll show you one. Professor Layton. He has an entire series. Look at this, how many games he has. He has, let's see here. He has 4 games that were originally released on the DS. Then he has 3 games, one of them being a crossover with Phoenix Wright. But he has 3 games on the 3DS. And I guess you could say they kinda had one on the Switch, but that's about it. They don't have any other ones. Like Curious Village right there is a really good one. Oh wait, what's this? The World of Steam. Is this a new game actually? Wait a minute. Is there a new Professor Layton game coming out? That was 2023. They say they will launch on 2020. New World of Steam. Did this actually come out? Oh, if it came out, I'm gonna have to go get this. Let's go to the Wikipedia. They'll definitely tell us. The new world. Oh, I see. Okay. Got it. All right, that's why. It's not out yet. Oh, that's so aggravating. Oh yeah, that's so unfair. So that will be out maybe in 2026 on the Switch to Switch Windows. So hopefully it'll come out. But yeah, here we go. Curious Village is awesome. The Pandora's Box is a very fun one. Unwounded Future was also quite great. And then these ones here, the prequel trilogy. The Last Spectre was quite good. The Last Spectre was quite good. I enjoyed playing it. It kind of dragged a little bit. I think it was because they were trying to add in a lot more other elements other than puzzly stuff. So it's not quite as good as the other ones, but it's still a good game. And sadly, I never got to play Arzon Legacy. I managed to get halfway through the Miracle Mask, and then my 3DS died, so I couldn't finish it. And I never played Arzon Legacy, so. I know of ways to potentially play it. I'll have to. Maybe if I can get them off of my 3DS. But yeah, see, these are all puzzle games like this. So you end up having a puzzle, you have to figure out how to go through it. You can use hint coins if you get stuck, but if you don't get stuck, then you end up getting you pretty much obtain maximum points. And the goal is to get as many points as possible. And I believe these are all currently stuck where they are. Let's see. I'm busy looking to see if there's a... Oh, where did that thing... Here it is. Oh, this one's on Android and iOS. So these three are on Android, iOS. Hey, that's quite good. That means if you want, you can... actually play them. It's a shame that the prequel trilogy isn't anywhere. Layton Brothers, Mystery Room. I've never heard of that one. I have some stuff to investigate. I'll investigate more later. But yeah, I play these types of games. Very fun. I was kind of hoping that the Pokemon one... Alright, last tangent. Let's see here. Pokemon puzzle game. I was kind of hoping that the... Where is it? It's the one that they just recently released. Okay, not that one. Not that one. It's not Pokemon Friends or Quest. I forget what it's called. There's a Pokemon game that's supposed to be tiny puzzles that you can do each day. Yeah, there's the... Right here. Okay, so it is Pokemon Friends. Alright, yeah, it's this one. This game right here is a pile of dog water. It is so bad. These puzzles, I wouldn't even call them real puzzles. Like, sure, okay, yes, they do have an element to them of puzzles, but they all are designed to be finished in 10 seconds. Like, look at this. They even tell you how long it should take. 40 seconds. That's... No. Come on, give me something that actually requires me to think, not something that I have to do in a very quick fashion. And you can only do a small amount of them each day. This is a horrible game. I do not recommend this at all. Nintendo should feel ashamed for releasing this. They really should. I'd have rather gotten a Picross game. Picross. I'd have rather gotten this. At least this right here is has a lot more use a lot more brain power than what they released. It's all about figuring out the different... Actually, is there actually any pictures of... Yeah, here you go. It's all about figuring out where a color is based off of where the numbers are located. For instance, here it says 10. And that means you have to have 10... You have to color in 10 blocks. And then down here you see it says 3. So that means you potentially have 3 down, 10 across, and then you just have to kind of figure out where they're located. I mean, this is... I've done so many of these. Man, they had how many? 9? 10. They had about 10 of these on the 3DS. I played every single one. I maxed every single one of them. Anyway, let's get back to programming. We need to modify our importer a bit. So our layering... Actually, let me show you what it's supposed to look like when we do it by layers. Or, sorry, by frame. I probably should have called this just... I should probably just import both of these until we get done. There we go. All right, now let's go ahead and run this. And there's our frame. If you look, there's my character. As you can see, he is all fully correct. This is a bit big, so it's a bit... I wish I could resize the image a bit. I'll have to look into how to do that. Oh, maybe I can zoom out? No, okay. Anyway. But yeah, you can see here he is. You can see everything is properly layered. The tail is in the very back. You can see that the body is above that, then the VR headset's on top of that, and then finally the eyes are at the top. So it works. It works fantastically with the frames. However, when we start doing this with the layer sequence, so let's go ahead and change this to layer importer. Oh, let's see here. Oh yeah, it needs to be lowercase. There we go. When we do that and we load it up, what we can see is it's not at all correct. You can see that the tail is on top, the body is at the very bottom. The eyes, the VR headset is below the body. Like, it's not at all properly organized. So yeah, we need to go back and fix the importer. It's understandable that it's not correct. Let's go to F. Yeah, here it is, FI. Yeah, it makes sense that it's not correct because I didn't actually program any form of sorting when it comes to the folder layout. I did when it comes to the I did when it comes to the frames. I did a sort. Oh, hey, why is this empty? Oh yeah, I see. Okay, we want to go to folder dicts, sorry. There we go, lab coat, happy, we'll check out fidget. And then here when we go in, you can quickly see it's all unorganized. Technically what we want is the second layer to be properly structured. Now the question is how would one do that? I can already think of a way to do it. And that would require just once we find out the folders, we then will organize them. So let's hop over there real quick and do that. Let's see here. You have a rather beefy computer, actually. Look at this. An i5 8GB 512 SSD. You could run quite a bit of stuff on that. I could already think of like a bunch of different. Oh, actually, I know a recent game that would actually be great for you if you're quite interested. There's a game called Starbirds. Let me show you that one. Starbirds. It is a puzzly game. Here it is right here. Starbirds. It's pretty much a resource management style game where you have to collect resources, combine all of them into strong or more complicated components, and then eventually you'll start building and trying to fit. Here's a picture. You organize out your assets on where they go, on how they get processed, and ultimately to try and maximize your score. It's very fun. It is very, very complicated. I mean, it is very complicated because you'll eventually get to a point where you want to make something really... It requires you to really think about strategy and how to strategize. Because you'll be wanting to build something with like carbon. You'll put in the effort, you'll produce carbon, and then you need to have carbon go to 4 different other planets because you didn't properly organize your how things are set up. So you either have to figure out a way to split up carbon production so that it can go to the 4 other planets, or you start reworking things so that all of the stuff can be done, all of the stuff involving carbon can be done on one planet. It's very fun. I am very addicted. We might play some of this a bit later. Yeah, I might play a bit of this more later today. But yeah, I'd recommend that game. Okay, where is our importer? Here it is, importers. So let's see. There's our basic importers. We want to mess. Here it is right here. So our folder setup. So once we have our... Actually, I think it might be this right here. Our layer names. I'm going to... Let's see here. Let's just actually type in sort. Let's see here. Sorted. Layer names. Okay. How much... I'm calling it now. I'm calling it now. How much do you bet this will fix my entire problem? One thing that I did is if you go in here, I ended up restructuring the data a little bit. So if you look, I actually coded all of the layers so that it will all be built in here. So you can see VRIs are on the top, tail is on the bottom. This is exactly how I did it when you look at frame sample. If you go to... Alright, where did you go, frame sample? If you go to frame sample and you go all the way down, you can see here I did the same organization. This is kind of this is a bit of a cheaty way for me to do it right now, so that way I don't have to program in defined layers. I can do that later. For now, we'll just get the stuff running and then we'll add in these features. So with that, let's restart everything. Let's run the animator code and run this and see, did it fix my problem? No, it did not. Okay. All right, it's going to be a bit more complicated than that. Yeah, it's still all messed up. It's all based off of how the data gets brought in. Oh, wait. This is the framer. Okay. All right. Wrong one. Let's cut that out. This was already working. I think I already... Yeah, right here. I already sorted the frames. Why don't we... Here it is, layer importer. There's the layers. Let's sort the layers. Yeah, it would kind of help to put the things in the proper location. Okay. Now let's try. And it's still broken. Okay. All right. I was kind of hoping that I could solve it that easily, but apparently not. So let's go ahead and start moving through here. So folder layers. So first things first, let's go ahead and let's see here. Here's import folders. Let's get our data dictionary. So let's get our directory path. If you remember, here's our... All right, let's go ahead and rename this so that it's more correct. All right then. So there we go. There's our our directory path. All right, we'll go ahead and run this. Self.layer importer. With that, we can now go ahead and grab this. And then the last is run locate bottom layer, which is right here, locate bottom layer. In this case, we start going down until we eventually find our bottom layer, and then we step up one. See, once we find out that we're now looking at items, we then step up one and start processing the folder layer. And then from here, we'll then input it back out. So here we then go down to here. So let's go ahead and set up grab one of the folder layers. So we'll go directory dict. And this should be simply like lab coat. Actually, let me go ahead and I'll just step through it real quick. Yeah, we already have the different components attached. Okay, perfect. So this means this would be an animation emotion, which would be happy. And then this would be a animation component, which will be fidget, because that's the best example I have. There we go. Oh, perfect. Folder layers. So now that we're here, first things first, layers. We grabbed ourselves layers. Where is here's layers right here. And then we'll sort layers. It did not sort it. Yeah, sorted right here. I was right, sorted. Did I have to? Oh, I see. Okay. Okay, I get it. I get it. Yeah, I definitely deserve the dummy face. Okay, I need to... Sometimes I forget. I wish that Python... I don't know. I wish that there was a way for Python to notify when I am modifying the existing element versus creating a new one. Because sometimes if I do something like this, like for instance, sorted layers, I could do, yeah, sometimes if I do something like this, it will modify itself. In fact, if you type in, let's bring in pandas. So if we have a data frame, we'll call this df. What you can do is you can do something like sort, and then there's a file called in place. See, it already changed it. And then from here, you can then set that to true, and that will do a self-modification. By doing it this way, you effectively do not have to say df is equal. Doing it like this with in place is the same thing as doing df equals, sort, like that. I kind of wish that this would be highlighted here as well, but okay. All right. So we now have this. Let's rerun the code. And this should have fixed the problem. There we go. It's now fixed. There we go. Perfect. Tail is on the bottom. VR headset is above the body with the eyes. Perfect. Okay. All right. Nice. Now then. So with that in mind, let's go ahead and commit our update for the importer. So add sort to layers in layer importer. All right. Oh yeah, we should probably add all of this. Okay. Moved old code to old src. Move old code. There we go. And we can worry about these other ones later. For now, yeah, we can worry about the other ones for later. For now, let's go ahead and start working on continuing with our animator. So now we have the ability to load images. Granted, this is using CV2. In fact, a lot of these are using CV2. Is there... Actually, does Pillow have a shower? I'm a bit surprised how slow... Yeah, image.show. I see. So we open up an image and then we do IM_show. We then just do show. All right. So Pillow does have it. Okay. So with that in mind, so this is our abstract base class. Let's go ahead and start copying some of this stuff over. And technically, we should probably have another class, and we'll call this CV animators. Yeah, I have a suspicion that whoever sees this code will probably go, "You're inheriting. Do not inherit. Inheriting is bad." But these are all going to be, they're all abstract. They're all going to get from the abstract base class, and this is going to be, the underlying code for this is going to be being used in these other places. So I don't see too much of a problem. There we go. All right then, and then from here, let's go ahead and start. Let's go ahead and start here. So this is going to be a pass. This is an abstract method. Oh, there we go, abstract method. Or we'll have to, Oh, actually, we're going to have to think about the typing. Yeah, we're going to definitely have to think about the typing. Because Pillow uses something completely different. It doesn't actually use ND arrays. It has its own special file, so we might have to put in here a union. So we'll call this an image union. And in this case, it will be ND arrays along with Pillow images. There it is, that one. All right. Put that there. This is fine. So what we'll do is we'll simply make this also an abstract method. Actually, I think it has a CV2 in it, so we need to abstract this out. And then as for compositing, or compiling the images, yeah, this will have to, let's go ahead and do that. That. And this will output. There we go. And then from here, we'll simply make pass. And this also has to be an abstract method. And then finally, this one here. which is also an abstract method. All right, I think that's good. All right, we don't need this anymore. Actually, you know what? Rather than completely deleting that, let's move it. Since we're now working here, there we go. With that being done, let's clear this out. I wonder if that changed. I think it did. All right, we'll go ahead and I'll go ahead and remove these myself. Actually, that should be a double. There we go, perfect. All right. So now that we have our animator abstract, oh, we should probably call this, oh, it has ABC already. Perfect. All right. All right, perfect. It already has ABC. So let's go ahead and move over to our CV animators. Here we go. Now this is going to be a all right. First parameter. Oh yeah, we already did that. Okay. All right, so now we have that. Yeah, this needs to be a ND array. All right. And I think that might be there. Okay. Yeah, I think that's good. I think that's good. So with that in mind, oh, image manipulation. Maybe we should start, maybe I should start implementing the image manipulation code. Actually, if you, hey, Urton, how's it going? We are building an animator tool. The idea is to simplify creation of my character avatar, because it's actually a giant pain in the butt to try and organize things and build it. I figured it'd be fun to get it all into one programming language, Python, and then from there I can just focus on drawing as opposed to, you know, everything else that is involved in building this thing. I originally did write the code though, but it is, that code is like, yeah, that code is, yeah, that code is really old. And because of that, it's, there's a lot wrong with it. There's a lot wrong with it. All right, so let's go ahead and make a class. We're going to call this our image manipulator. I don't think we're going to have to worry about too. I think we just need the one file, because the idea is that so the general idea is that this image manipulator file will pass it in for when it comes to like doing the compiling, and it will then then when we start putting the thing together, it will look at the image manipulator and say, oh, at this particular frame we want to do this, or oh, at this particular, I don't know, at this particular, you know, at the very end we want to do that. And then that way we can have the exact same image manipulation code just being used wherever we want. So when we want to do it frame by frame, I just need to call this more frequently than, when I want to do it layer by layer, which means I usually do it at the very end. So with that in mind, because of the actually, I might need to make this an abstract, because we're trying to build it for 2 different languages, if you remember. So I might need to actually, because it's an image manipulator and we kind of already know what the formats are, we can just probably do an isInstance, and then I can just focus on that. So all right, so let's do that for now. So first things first, we'll do a define, and we'll do warp. And in this case, we'll take in, let's do a, let's see here, from Animator src dot and animators dot animator import. We want the image union, and then from here we'll then bring in an image, which will happen to have the image union typing, and then this will output an image union typing. All right, then, so we have that. An illegal target for a variable annotation. Why is that an illegal target? Maybe that's just messed up. Actually, the best way to figure it out is to run it. Yep, expected error. Oh, I see. That should not be, there should be no space there. There we go. Okay. Yeah, I knew that was something weird. All right, anyway. Now then, what we can now do is we'll define a warp CV, and this takes in as a ND array, and this will output a ND array, and then we'll have warp, and this will be pillow, and then this will, oh yeah, we need to call this image. There we go. And then here, image. Make sure I have my fingers in the right place. And then we'll simply output the same thing. Or actually, because this is a pillow, this is going to be an image. So there we go. And then from here, let's go ahead and import these. Yeah, there we go. Perfect. All right. Oh, and we'll also want to put the dots at the end. There we go. Perfect. And then from here, it's just simply if image, or this is an isInstance, image, if it happens to be a ND array, then what we'll do is we will run warp CV image. And then here, if it's an instance, if this happens to be an image, then we'll run the warp pillow. Then finally, if this would end up being a value error, which is not in image format, or image format, or yeah, I guess you could say not an image format. And then what we'll do is we will output image, the type for image. And I guess we'll put in a something like that, and then we'll type out the image union. There we go. Perfect. And there we go. And actually, I think what we should probably do is we should probably set up a log here. So I'm going to put a log here. Let's bring in logger. And this happens to be an info where we have, we'll simply type image warped. All right, there we go. Image warped. Part of me wants to put a name here, but I don't think we need to worry about that. The main thing is we just want to say we warped the image. Oh, I know. Image warped using, and in this case we want to put these in here. So image warped using CV2. And then here we'll have image warped using pillow. PIO. Now then, in my old code, where are you? It should be framer. Because I actually wrote this warping code already. Yeah, I did this originally to make my character easier to bounce. Here it is right here, warp. This happens to be, let's see here, image transform. So I'm using pillow here for doing the transformation. Yeah, I'm using pillow here to do the transformation. So if data is none, then we just return the image. And then from here, we then perform. All right, so let's go ahead and grab this. Warp using pillow. Image, transform image, image.transform, perspective, and then data. So we need to have the amount that we're going to warp it. So in this case, this will be the warp matrix. And this has to be an ND array. Let's see here, warp matrix. Oh, I'm just going to make this easy on myself. There we go. There we go. And then let's go ahead and just add these in. And we'll set this to return that for now. There we go. Image transform. Image class does not have a transform. Wait, I remember it having a transform. Let's see here. Well, to be fair, actually, let's me go to the really old code. Here it is, old Animator. Here's the warp presets. Let's see here. So image, get frame, emotion, sequence happy, warp preset 0. So here's get frame. I call sequencer get frame. So frame.show. What in the sorcery is this? Nothing really. How's it going? I am busy programming an animator. The idea is that it will help streamline the building of, or the making of these animation videos. So if you notice, my avatar is quite he has a lot of emotions. I can have him standing still. I can make him angry. I can have him look at the camera. I can have him look like a derp. And you can see they all have these little tiny animations. For instance, if I change my stance, I'll change it to the derp. You can see the eyes kind of grow big and the tail moves in a derpy fashion. And then likewise, I can also have him play games or hands in pockets. I can have him do anything. This is a lot of pictures, a lot of frames. And to generate these need to all be videos in order for because the idea is that I'm using a video encoder to have these videos in memory so that I can call them whenever I need them to move around. But making these videos is a massive pain in the butt. So what I'm doing is I am writing code to simplify all of it. Yes, the mouth is on the shades because originally I hadn't. So I have a the idea was that you'll never see the character's mouth move. You'll just see his expressions through the VR headset. Hey, it's just a works. It just works. How's it going? I mean, because this is what originally my character was going to look like. It's going to be a very deadpan, and yeah, it's very, very deadpan. Not very. You can't really tell much what is going on. So yeah, I gave him a headset so that we can kind of see what's going on, and you can actually see the mouth. Though I'm changing that I'm currently updating my character, and I'm changing it. So sadly, the mouth is going to be gone on the VR headset pretty soon. Python is quite an interesting language, isn't it? Okay, so we need to... Boy, Oh, thank you. Okay, I think maybe I need to go even older. Let's see here. Here's warp presettings. Okay, where did... Yeah, all right. I have a suspicion that because I've been modifying the code, I'd probably have to go to an even older version to get the warp. So why don't we just quickly go over to Pillow? Let's see, Python, Pillow, warp. In C, does it actually have the transformation? Here it is, right here. That's the... Oh. Actually, this is exactly what I need. Haha. Oh, this is perfect. Code Raven has both the opencv and the Pillow syntax for doing this. Now, as I mentioned, I am trying to make it so that building the videos will... Oh, definitely. I am tired of Google. Google is such a... I hope that the company loses so much money that it will stop being what it is, and it will actually go back to being just a search engine again. Here we go. So, matrix calculations. There it is. So, PIL image.transform. Image transformation. That does exist. I am not crazy. Yeah, I am not crazy. All right. So yeah, I wonder why it's not there though. Maybe we need to from pil.image. Actually, how much do you bet it's from this one? Import. Yes, I am right. Okay. We'll go ahead and do that. Okay. All right, perfect. So with that in mind, we now have, unironically, we have our warping for pillow done. This is I know it's a static method. We'll worry about the staticness later. How about we, instead of just outputting this immediately, we'll do this here. We'll call this new image or warp image. This is going to be an image file. And then we'll return warp image. Ah, I know what you're doing. Yeah, it's surprising how common Python is in the working or in industry. I kind of thought it would be more of Go or C++, but surprisingly, a lot of them just use Python. And when I was there, I did an awful lot of it was a lot of network stuff. For instance, they call it ETL. If you heard of ETL, it's extract, load, and transform. Or in this case, is extract, transform, and then load. But yeah. So let's see here. Yes, I'm actually a bit surprised that not very many people do that. I mean, I had so much fun drawing. It might be because it's so much time. It took me about a week and a half to draw all the pictures, and then it took me about another week to compile it all. So maybe they just don't want to. Maybe they just don't want to have all the different emotions. I'm hoping that once this is done and I have everything figured out and sorted, I can hop over to Zig. So I'm actually trying to learn that. So let me hop. Let's see here. Oh, actually this one. There it is. I haven't touched this in forever. Okay, then. I haven't touched this in forever, and I'm pretty sure that the code... Yes, this is Ubuntu. Oh, thanks for the subscription. Yeah, this is... this right here, I'm using Ubuntu. Largely because I'm actually... I have a separate computer running all of my code. That way I won't overload my current computer that is doing all of the output of the stream. Let's just go ahead. I'm very worried about how much is in here. We'll go to... Yeah, okay. I'm still learning Zig, so if you look, there's not a lot here. But yeah, as you can see here, I am... busy going through trying to write up this code in Zig in the hopes that I will, instead of having to create a bunch of different videos, I'll just have folders of all of the pictures and they will be streamed into a video buffer so that it will then display it. I'm hoping that I can maybe have a 30 or 40 millisecond delay so that my character still seems fairly smooth in whatever's going on screen without it having being too much of a processing hog. I tried to do it in Python and it died. Python was too slow. So yeah, let's see here. I wonder if there's nothing here. Because of the fact that people love using AI, I did say, hey, AI, write me some Zig code. And it generated this. And it looks good on the surface. I mean, if you look at it and think, oh, hey, this looks pretty good on the surface, I think that I could get a lot out of that. And then once you start digging in, This is probably like the worst Zig code I've seen in a while. And I'm not that familiar with Zig, and I already can tell you it's effectively dog crap. So I'm going to have to figure things out all on my own. Anyway, first things first, let's get back to Python. All right, so we have our warp here. And from here, actually, since we found the code already here, this is the warp, right? opencv. So we take the height and the width. They shear, which will be around new shear. Then they apply a, here it is, get perspective transform. So there's a function called get perspective transform in CV2. So CV2 there it is, get perspective transform. I am from Arch Linux, but then just today I am using for SIEM. I'll have to look up what that means. Okay. I've apparently because I've been digging, I've been wanting to move all of my systems over to Linux, largely because I hate Windows. I mean, Windows is, I do not like how Microsoft is running things in Windows. I don't like the direction that they're going, and so I want to just get off of. I just want to get off of it, and because of that, I'm trying to figure out the best code. I'm trying to figure out the best on what to do. And one of the things I quickly learned from people talking about in Ubuntu, or I should say in Linux, is that there's an awful lot of dependencies going on. For instance, if I want to use a program called GIMP, GIMP is a graphical image manipulation processing software. So there it is right here, GIMP. Or they call it GNU, graphical image manipulation program. All right. But yeah, if you try to install that on a different computer, because it has some of the dependencies in Ubuntu, and then those dependencies in Ubuntu need the entire operating system of Ubuntu. So you might accidentally install a brand new operating system on your computer just to use this one program. Okay, to be fair, I think GIMP doesn't do that anymore, but I do know that there was one software that did that, and yeah, it can get a bit of annoying. It can get a bit of annoying with how many dependencies sometimes show up. Scalable. I hope to have it scalable. All right, either way, let's see here. All right, part of me wants to just type it out, but part of me wants to, let's see here. So here's U1, U4, U2, U3, and then this is what it looks like when you perform the transformation. So initial vertices and final vertices. Ah, I see. Actually, that's actually kind of nice that it explains that a little bit. And then I bet this is probably the same thing, isn't it? And the answer is, that's coefficients. There's find coefficients. Let's see here. Here's their program for finding the coefficients. Oh yeah, I do have that, don't I? So let's go ahead and get that in here. Let's okay, yeah, let's 1 second, let me see here. I believe I might have parsed this out, didn't I? It's not in tools anymore. Let's see, find here it is, right here. In the video generator, find coefficients. All right, so let's go ahead and copy this. This doesn't need to be in the animator anymore. This needs to just be right here. Oh yeah, I'm definitely gonna have to write up all of this. Oh. And this happens to be a static method, but we'll go ahead and leave it like it is for now, because you never know, we might want to. All right. There we go. I see. Ah, okay. I can probably try and explain a little bit. So, okay, let me try and explain a little bit. So let's see here. So this right here is PyCharm. It's a programming, or yeah, this right here is PyCharm. It is used for writing in Python. I think anyone who, I think many people are, you can use any different language. I'm using this largely because I'm more familiar with this. I'm trying to get into NeoVim so that I can start using NeoVim to do all of this. But for now, I'm using what I know. And this is my data structure over here. And let me go into what I was working on, which happens to be the image manipulation code. Up here are all of my, these are all the dependencies that I have. CV2 is an image processing library. NumPy is a number processing library. Pillow is another imaging. Then logger, or logger, this is for logging, as in, oh, I need to make sure that I output some information. So this is what that is used for. And then this just happens to be from my actual data. I'm pulling it from Animator, which just happens to be the image formats that I want to keep track of. And then lastly, I'm just making a class. This is object-oriented programming, so I'm making a class. I know that it's fun to look online and watch all of the people have a major debate. What is better? Do you think object-oriented programming is better? Do you think that functional programming is better? It's very interesting to see the people having these debates. Because a functional programmer will say that it's a lot more efficient to just write a bunch of functions, while an object-oriented programmer would say it's a lot more efficient to have everything stored in independent files so that you don't have to... keeping everything in this self-contained makes things just a lot easier to read and run. So it's kind of fun. This is the image manipulation software. This is for modifying my images. So if we go to the code that I wrote earlier, here, you can see I have a image already loaded up. We load that up. See, there's my avatar right there. As you can see there he is. Originally, everything was not properly organized. Yes to OOP. It's very difficult. It's a very interesting, difficult conversation, I see, because I see the pros and the cons in both the directions. I currently like doing object-oriented programming more, hence why I'm doing it this way, but I know that, like, Go, for instance. Go is not object-oriented. So if you're going to do anything in Golang, it all has to be functional. But I digress. All right then. So here is my image manipulator. We're going to perform a warp. So here I'm taking in an image, which could be one of the union. This happens to be a ND array or an image file from Pillow. And then based off of what the format is, we'll then run warp. And then here is basically the warping. So in this case, I need to, let's see here. In this case, I think that because we need to use the coefficient, this coefficient variable for doing the warping right down here. So let's see here. How is this working? Oh, this is just finding the coefficients. So we have find our x and our y. They're turning that into an integer. That's our shear x. And then that'll be our new w. And then we find our coefficients. So that's taking in the coefficient matrix. And then finally, after we have the coefficients, we then feed it in. And that will be our modifier matrix. Oh, and then they added in a resampling by cubic. I wonder if we need to do that. All right, be sure, go get some rest. It's good. I am a neurobiologist by trade. I've learned a lot about sleep. It is very important to get a good amount of rest. Let's see here. Where is my, 1 second. I should have probably loaded this earlier. Oh. Yeah, I probably should have loaded this earlier. 1 second while I load this up. There we go. There we go. Yeah, I am a scientist by trade. So I can provide lots of information about biology if you need, particularly pertaining to things like regeneration, sleep. Yes, I studied neuroscience. Hence why I have the biology tag in my videos. Because you never know when someone wants to learn about eye regeneration or how sleep helps promote growth. Either way, let's get back to this. All right, let's see here. Actually, if I remember in my old code, sorry, I'm going to go back to my old code. Let's see here. We're wanting to find coefficients. It's sequence builder right here. We had a PA and PB. This is defined bound. As you can see here, I programmed it originally to. Okay. Oh, I look forward to questions. Questions are. That's a tangent that I probably should not go on, so I'll just be very brief. I despise how schools today prevent people from asking questions. I understand that if you have 30 plus people, then it will be difficult when you have questions happening all the time. But asking questions, that is the fruit of learning, of gaining knowledge. And there are so many ways a classroom could be structured that would help promote and incentivize students asking questions. So, I could spend hours complaining about that. either way, let's not go on a tangent. So here's our bounce, there's our image, there's the bounce size, and then from here I ended up generating the actually, you know what? I'm going to copy this too. I am going to copy that too. Image manipulation. Let's go ahead and put that here. I'm going to put this here at the top, because the idea is that, let's see here. I think what we'll do is, this happens to just be the image parameters. So what we can do is we can just input the image here. So we'll just put in image. And then from here we'll have, let's see here, from here will be the image union. The bounce is going to be a certain height that we want it to be. It'll output an ND array. And then from here we'll have image size, which will be the let's see here. I would like to say shape, where we go to the second. Yeah, I'd like to say it would be shape. Actually, my big question is the, all right, let's import image real quick. So there we go. Let's import image. So, and then from here we pretty much need a path. How about we go grab one that we already defined? Path list, perfect. Let's grab the first one from path list. Oh. 2 were given when it comes to, I think it actually might be I am read. I need to probably put that in there. Image, okay. How did I load it again? Let's see here. Let's see, old animator. Here's get frame. Oh, we probably want to go to framer, because that's where everything would be loaded. So image dot there's colorize, so I have a lot of things I'm going to be snagging here. Image mode. I think let's see, image size. Oh, actually, quick question. Image size. How do we structure image size? It was a tuple. There it is. Width and height. Okay. That's good to know. Yeah, that's good to know, because since we're modifying the code up, we'll need to be able to keep an eye on that. Bit depth, image size, warp presets. As you can see, the code was written. This code right here was written to try and be a pipeline between images to a video output. So here's compile. There's the layers for compiling. What we're looking for is that's reordering the layers, add layers. Here, add layers. Image location. there's the image path with long listing, and then we go to add layer. Man, this is a lot of code. Components, inserts. There's the image path, there's the image name, or there, I think it might be faster rather than going through my mangled mess of code here and just look up pillow, load image. Let's just do that. In fact, I bet right here it might even have that. Here we go, pillow. Actually, it doesn't, interestingly enough. Oh, here we go, full example. Open, there it is. All right. Okay, it's so easy, it's just open. Okay, let's have a derp face for now. All right, so here's the image manipulation, our image manipulator. So here, let's type in open, and it complains. Why? Image attribute does not have open. But what do you mean it doesn't have open? Let me guess. It's the first image. Got it. All right. Okay. All right. I have, since this is going to get very confusing, let's just import image, like so. Then from here, we'll put down image.transform. From our let's change the union now. Okay, so yeah, perfect. So the union's fine. Image.image, so this will be out. This is the type right here that we need. So yeah, that's our type. The typing is good. We're going to be running with pil.image, which is also good. Transform is, now we know where the transform is coming from. So let's go ahead and import that. Let's open up our image. Now then, let's see here. So here we are. We are a pillow file, an image. We are RGBA, our size. So most likely it's image.size. All right then. And let's see here. And then we should have image list. Perfect. Let's go ahead and grab this one. We'll call this the CVIMG. So now we have, and we'll go ahead and call this PIL image. So now CVIMG.shape. And then how about we go, does this have a size? It does, but they are two completely different things. I kind of thought so. So yeah, we're going to have to, when it comes to finding the sizes. So what I'm going to do is we're going to create a, this is just for making it easier to know what we have. So we'll call this the utils. These are the utility code. And this will be get size. How about we call this get image shape. This will happen to be image. which is the union. And this will output a tuple that will happen to be 2 ints, like so. Now then, if... okay, there's going to be a lot of these is instances. Okay. I don't know, maybe... Okay, we have to... let's think for a sec. Let's load up our... let's load this up real quick. This is our little drawing board so that we can kind of brainstorm. All right, then. So let's think real quick. All right. So the idea is that we're going to have a frame right here, and we're going to want to warp it somehow. We have CV2 and we have pillow. Both of these have their own functions. Then they're unique. So unique functions. That is the worst functions I have ever written. Oh my. Oh. My handwriting, it's so bad. Okay. These have their own unique functions. So for our image manipulator, we can either have it break down to CV2 specific and PIL specific, or we can have it together, as in we put both of these together into there, and then we just have to do a lot of if-else statements. This way would mean that I just have to call the one file all the time. This way I would have to make sure that everything lines up. Actually, I think from this particular case, maybe it's good to separate it out. And because one thing that you can do is, since these are all objects, we will have our, we're currently calling it Animator class. Actually, no, not that. I'm thinking, because the idea is that this is going to only work on a frame. Our frame. So because of that, the animator does not matter. It all depends on this frame and when it goes in. I think we're going to stick with the if-else statement stuff right here. Yeah, I think I'm going to stick with that. Largely because it helps reduce a lot of the front end thinking that one has to do. If we leave it to the back end, then I won't have to go, I won't have to think too much about it. That's kind of what I'm trying to do right now with here. With that in mind, maybe I should, let's see here, where are our... I might need to start compiling the animators as well to just work either or, because we know what the image formats are that we're going to be inputting and outputting. I don't need to manually set it up. If we want to manually set things on how to work, I can probably put in toggles to switch between the two. And yeah, I think that might be the best. For separating them out like this, it needs to be something that really is important. For instance, for video generator right here, that we're... Okay, maybe not that one. Okay, not that one. Where is it? Builder. Okay, not that one. Art generator. Here it is. Okay, art generator. Yeah, this. If you look here, I'm building an abstract. It's basically an abstract basic class called Art Animator. And in this case, it'll have two outputs, video generator and image series generator. So these two will actively output a file. Oh, we have spam. Let me delete said spam. We don't like spam, so let's go. One moment. I need to report. Let's see here. We're going to report. One second while I report a bot. There we go. Reported. All right. And then let's go ahead and delete this now. There we go. Aha, perfect. And the world is one bot less, which makes the world a better place. Okay, but yeah, if you look here, as you can see, I have it set up so that it will if we select video generator, it will output our list of images as a video. This needs to be expanded because, well, there's a lot of other things that need to be, it needs to be expanded, I guess is the best way to put it. And the same thing here with the image series generator. The idea is that it will go through and actively output images. Currently, if you look, it is set up as a... Let's see here. This one is using CV2, which is what's... Oh, yeah, this is currently using CV2. Yeah, I'm going to go back and start combining the animators. I think that would be the best course of action. If we want to change the way that the animator works, then I can do that, but I don't think I should separate it out based off of CV or Pillow. But yeah, here, you can see here, we are, I am using CV2 as a way to output video, using their video writer. And then for the image series, I'm using Pillow. So I'll need to update that a bit. But you get the idea. So with that in mind, we'll just simply continue with the is instances. In fact, I could probably offload this. So let's go ahead and do that actually. So fine. Get image format, and then from here we will output a image union. There we go. We're going to import in an image. And also with that in mind, that means I can start turning these into static methods. Let's see here. This would be a true, this is a true or false. So can I return, we don't need that. I can do a type. And then likewise, in this case, this is going to be image.image. And then we're going to return this one. Actually, you know, I think I think that actually I had I thought this was going to be a good idea, but thinking about it, I think I'm just going to be I wish there was a case switch function here. This would be perfect for case switch. It really would, but Python doesn't have case switch. So I have a feeling that this is, I'm just going to keep throwing out is instances. So we'll keep this format right now. Yeah, for now. Explicit return expected. Oh yeah. I'm going to set this to return, but this is going to throw a value error, which means it's going to. This is an exception. So, yeah, it's not going to work. There we go, optional. All right, I'm adding the typing up here. It's actually surprising how, yeah, it's actually a bit surprising sometimes. I'm watching people on, I watch people doing programming on stream, and I don't often see typing. At least when it comes to Python, which is a bit strange. Okay then, so yeah, I have a feeling that we're still going to be doing this forever. So I'm just going to copy this. So get shape, here it is. So if the image happens to be an ND array, then we're going to return the shape, but it's going to be just the first two values. So there we go. Hey, EXO, how's it going? And then for this one, because it is a pillow image, this is going to be size. And then from here, we're going to have to put also an optional. Doing well, doing well. I'm busy. I'm having fun programming right now, trying to figure things out. There we go. Let's go ahead and actually, let's bring the typing in as well. There we go. And now it's complaining. I wonder why. Generic should be specified through square brackets. Oh, yeah. Yeah, that's true. That's true. There we go. Okay. You went to a fair today. Oh, that sounds fun. What kind of fair was it? All right, so with that in mind, make return none statements explicit. It's going... all right, we'll do this, but it is going to... when you throw an error in... This is a silly moment for the PyCharm. When you have an error show up, it's going to automatically break the code. That's the function of an error code, an error message. So if I ran this right here, since this is static, we can go ahead and just build it. Oh, optional is not defined. Let's go ahead and define these. But yeah, if I go ahead and run this like so, and if I type in now get format, we'll put in a 5 as an integer. Wait, why did it not send a... Wait a minute, why did it not send the error? There's supposed to be an error that throws up. Oh, wait, you're supposed to throw an error. Oh wait, I think I know what it is. Exception. I forgot to add that in. Exception value error. There we go. Let's try that again. And it didn't work this time either. I remember the errors being able to be thrown like this with no problem, so... Let's see here. Oh, alright, let's see here. Ride with some extreme rides. There are games like Pop the Balloon and Shoot Basket. Oh, that sounds very fun. So it's an actual fair. Kind of like one of those, yeah, it's an actual fair that you would go and spend time. There's a, there is, let's see here. It's not exactly a fair, but if you go to it's called Ocean Park. It's very fair-like in part of the section of it. So there it is right here, Ocean Park. I don't think, yeah, I don't want that Ocean Park. I want this Ocean Park right here. Yeah, this is it right here, this Ocean Park. They're suspending the app. Oh, I wonder why. I wonder why they're suspending. Anyway, let's see here. Where is the... let's see here. Panda Zone, shopping. I'm looking for the back end of the park. Is it this thing? Okay, it might not be this one. There is a part in Ocean Park. Maybe if I find a map. I wish that this wasn't in bright mode. It is way too bright. Park information. All right. Let's go to Hong Kong Ocean Park map. There we go. That's what I want right here. So this is the Ocean Park map. I'm surprised that it's being... Come on. Don't... this is very annoying. Okay, anyway. I hope you can see it here. Yeah, this is being very annoying. Anyway, if you go over to this area here, particularly this part right here, the marine world, this is set up very much like a fair. You have lots of kiosks with prizes in them, so you can try and throw rings onto bottles, or like throw darts, or a variety of different of those games. And then they have Ferris wheels and other types of rides. I think there's right here is the extreme ride, where it effectively spins you in circles while that thing is going in circles. I'm calling it the Vomit Comet. That is a horrible ride right there. I refuse to get on it. But yeah, you can see it even right there in the picture. You have a big long arm, which is spinning in a circle. And then you have this little kind of Ferris wheel area that is also spinning in a circle. And then you're just spinning and spinning. And yeah, that, again, I can guarantee vomit everywhere. Oh, hey. I haven't been to... This was being developed before I... so I need to go back to try that out. This is a very interesting park. It's actually built on a mountain. So you actually have to take a gondola to get from this area to this area, the summit. You have to take a gondola, or you have to go through an underground train that cuts its way through the mountain. It is very fun. I would definitely recommend. Actually, let's see here. If you love horror, let's see. Ocean Park, Halloween. Yeah, if you love horror, every year, they will have a lot of Halloween themed rides, and you can pretty much, they're a variety of different things. One of them was a VR experience. You would walk around with these VR headsets, which would is kind of like augmented reality, and then you would go through a haunted house with these VR headsets on, and then ghosts will be following you around or trying to spook you, and it's very fun. Can I get in here, Halloween Fest, please? Yes, I know. Open the box. Long press. Okay. So yeah, and see, they have a variety of different ones, a variety of different rides that you can go on. Sadly, I never made it to any of these because it's always booked when I'll look and go, oh, hey, it's October 1st. I should totally book a day to go visit this thing. And then it's all booked. Like, this thing is super popular in Hong Kong. Oh, and another thing that's also fun, I don't know if they do it right now, but there is a case where sometimes the people who are dressed up in the masks that are in these haunted houses, they'll actually be allowed to wander around the park. So you might be sitting on a bench and then the Grim Reaper will show up behind you to say hi. So it's a very fun experience to go to here. Oh, at least I've heard. I'm very jealous because my wife went to these before, and she has tons of photos of her hanging out with the ghosts and goblins and such that were part of the rides. So she would definitely recommend this, yeah. But yeah, that's right. This area here in Ocean Park is very fair ride. It's a very fair theme park, or you know what I mean. You know what I mean. Anyway, let's get back to writing our code. So pretty much we'd simply do get shape. We'll then see if it's an ND array, we'll grab those. If it's a image, we'll then grab that. Actually, let's see here. PIL image dot size. And then, so that should be the width and height. And what about our CV image? We want to go to size, shape. And it is reversed. That is another thing we also have to keep an eye on. Okay then, so the format, the output format, so output is width, height. So with that in mind, this needs to be reversed. So why don't we do that? Oh. No, come on. There we go. Something like that. There we go. So now both of these output the proper size. So from this, when we type in get our size or get image size. So yeah, so self dot get image size image, and then this will simply be the width and the width, or the width and the height. And actually, can I put down the typing here? I can. Okay. Or I cannot. All right, there we go. Now with that in mind, we should probably do the same thing here. So let's go ahead and grab these as well. All right, so now that we have that and that, the next thing is we need to do the coefficient. So self dot get image format. Oh yeah, I have that here right now. So what we want is find coefficients. This is looking for a PA and P. Oh yeah, this is why we have the bounce function right here. I'm thinking. I am busy. Yeah, I'm thinking. Because this is ultimately going to run through a warp. This is to find the coefficients right here for when we want to do the bounce. Hence why this is called define bounce. So let's go ahead and copy. In this case, we just need to run this right here. And then this is going to be a tuple. Technically, I think what we should do is we should just change this to width and height, like I've been doing. And because of the fact that this is showing up so frequently, we should probably define this somewhere. So define bounce really should, yeah, define bounce really should, yeah. Because the idea is that instead of just defining the bounce, how about this? Let's go back to our old example. This should be in the old animator. Or, okay, maybe not. It should be in Framer. Compile, image size. Okay, where is this again? Okay, find coefficients. Sequence builder. Okay then. So this is in the why is it in sequence builder? I do not know. All right, here's defined bounce. So here's our image. This is the bounce that we want to define. I see. So this is where we're doing the warp presets. Okay. Yeah, again. I wish I had a more of a. I think I might expand the emotions out a bit more. For instance, not just happy, but it would be like super happy, or not just derp, but like brain caved in derp. Because now that I go back and look at this, like why is everything the way it, like, for instance, why is define bounce here when this is supposed to be a frame specific thing? For instance, now that we have this, and I bet it will go straight into the animate. I bet this will now be fed into the animator where we will have presets. So let's see, is warp in here? Yeah, here's warp. So warp is here. Yeah, warp data, and this is we're going to go for the first preset. Yeah, here it is. Then this is warp. So yeah, image transform, and then we use the coefficients. I don't know why I did it this way. Either way. So the idea here is that we're going to, this is the matrix that needs to be modified. You can see here's the PA and here's PB. These are the two matrices that are needed for finding the coefficient. This is effectively the first, this is our image right here. Yeah, this is the layout of our image. And then this right here is how the image is going to be modified. This is one reason why you can see that we're looking at image size. I wish there was a nicer way to view this. Let me see if there's a way to view this. Let's see here. I guess something like this. So this is all about matrix calculations. So here we have the matrix right here. In this case, you can see we have our it's a very complicated. How about this? Why don't we just run this and see what the output looks like? First things first, though, let's set image size. And then pillow image, there it is, dot size. Okay then, now let's go ahead and run this and see how it turns out. All right, so there we go. Now let's grab this and then modify or format it so it would be easier to look at. Actually, if you look, it's kind of a sequence. It's a vector, but we'll go ahead and do that. Oh. It's a vector. There we go. So here, there we go. So as you can see, these are now these are technically the points in which our data is located. It's our matrix. So that's what our matrix will look like right here. This is what we want. This is how we want to modify our matrix. So let me go ahead and redo. Let's go ahead and set bounce to something silly like 25. And then we'll rerun that. We'll run this one here. There we go. So as you can see now, everything's kind of been shifted up about 25. You can see right here, 25. Yeah, everything's been kind of shifted. This one got shifted down a little bit. This one didn't change. These two didn't change at all because this is width. So these are all affecting the height, and these are all affecting the width. And then these are the points these are the points of the width and the height. Think of it as this is the first pixel, this is the last pixel, and then this is the first pixel and last pixel of the height and again of the width. I hope I'm explaining that right. I hope I'm explaining it right. But the main point is as you can see here, this is what our original image is going to look like. This is how it's supposed to look at the end. And then when we feed it into our transformer, when we feed it into the warping code right here, it will adjust the image. That's the idea. So let's go ahead and just make this a bit easier. So we'll call this H. This right here is W. This is H. And then this will be W. H. Oh, hey, we can actually put everything on the single page now. There we go. Now this is also H. Hey, it actually makes things a bit easier to show off what I'm talking about. And then from here, we're now going to be at H. Here's the W. Here's our H. All right, W, H, and then this is lastly H. So that's our... So instead of calling this define bounce, what we're just going to do is say this is bounce. We're going to find our coefficients right here. So this will be the warp matrix right here. Now that worked. I think I can probably maybe get that up there. Yeah, I think that's good. All right, and then last but not least, what we'll then do is we'll then do warp or self.warp. We'll put the image in here, and then we'll put in our warp matrix. And this will be returning, there we go. So there's our bounce. We find out what our image format is, so we can get our width and height. We then calculate out the coefficients, and then we pass it in through warp. Now, it works fine when this is an image, because if you look here, when we run warp pillow, we're looking for our warp matrix. We haven't programmed the warp matrix in yet here. So with that in mind, let's hop back over here and see about our... this is the pillow. Here it is. If you look, they put their... It is the exact same code. If you look, structurally, it's the exact same. If you see here, it is a... Let's see here. If you look here, it's the same as this one. It's just slightly different. In a sense that this is now an ND array. They put it as a float 32. I wonder if a float 32 would be sufficient. If I change it to 64, it'll be it'll eat memory up like nothing. It'll make memory will be potato chips. That's what it'll be if I put it all at 64. But 32, I think 32 might be enough. We'll go with 32 for now. But the idea is that it takes the values get perspective transform, which would be M, and then they do warp perspective. New width, new height. Okay. They end up doing that, the new width, new height, because they want to be able to show how much it's sheared. That's what they want to do. We don't care about that. We're keeping the same width and height. So, get perspective transformation, which is interesting that they're not using... I think it's fine though. Actually, you know what? I wonder... Well, actually, we probably should keep it separate. I was just thinking, hey, it would be kind of fun if instead of us doing the calculations, we just do get perspective transform with CV2. But because we want to keep opencv and pillow separate, it's best to just keep it separate. This does allow me, though, to contemplate and see. I wonder if this is faster. We probably should do a test there. But for now, let's see here. For now, let's see. This is already looking for a warp matrix, which means we should probably instead do the calculations here. All right. We can keep the size. Yeah, we don't need the get perspective now. What we need to do is the this one, warp perspective. So cv2 dot warp perspective. Then we have our image. We have our warp matrix. And then from here, it should be a tuple of our width and our height. So in this case, what we can do, oh, actually, question. It is width and height, right? Yeah, it is. It is width and height. That means we can call this the image size, which is going to be a tuple with a bunch of integers in it. In fact, we know it's already going to be 2 integers. Put the image size right here. There we go. And we'll want to return this. This needs to be moved. Oh, this needs to be moved up here. So, now, all right, let's go ahead and put this right here for now. Now the question is, oh, this should be a, yeah, oh, wrong. This should be image.image. There we go. All right then. So now the big question here is, yeah, the big question here is how are we going to structure this? Yeah, the big question is how are we going to structure this? Should I input in a... Because right now, as you can see, I have the coefficients already established here. If you look at bounce, it is all already established. We have the PA and the PB defined. But because this is all using internal code, we're not actually using the get perspective transform for CV2. It needs to be an ND array. I'm wondering if again, I'm trying to think of a way to set it up, because potentially what we could do is we could just forego using get perspective and then just take whatever our transformation is, and I believe it actually outputs a... We should probably put down what this is, right? It's an ND array, isn't it? Yeah, it's an ND array. So technically, we're already doing that. We're already getting an ND array out. So I could just pass that through like this. Because for the get perspective, it looks like we should put it... We're going to put in our... We're putting in our two... we're putting in these. We're putting in the PA and the PB. These are the two matrices for which we're going to do the transformation to. How the different pixels are going to be warped. I think maybe we should probably write in a code here, because I'm just trying to think of actually, maybe I don't need to, because I already have bounce programmed in. I mean, that's right here. How about we do this? Let's just run the code first and see how things fare. So here's our image manipulator. Let's run that. We'll go ahead and make this, let's see here, we'll call this AIM. Image manipulator. So first im.bounce. Let's go ahead and put in our image. We'll put in, we have PIL image. Let's have it bounce 25. And we'll call this A. Oh, here we go. Find coefficient missing reported. PBA, PB arguments. Okay, let's see here. Oh, okay, yeah. That's gone. That's gone. In fact, all that's gone. Okay. Okay, let's redo that. Let's try that again. So there we go. We have A. We've warped A. Now let's see here. We should have, there it is, A. Oh, what is A? A is empty. Oh, why is A none? Why are you none? Oh, because we're not returning anything. Okay. Oh, we haven't set the returns yet. All right. Well, let's call this the okay, let's call this warp image, which will happen to be a from the image union. All right. And then last but not least, we're going to return our warp image. There we go. Okay. All right, let's do this again. Oh, come on. There it is. Okay. And unsupported file type. All right, let's look. Where are you, image? Here it is, A. It's a pillow. Oh yeah. We are currently only working with CV2. Okay, let's all right, let's change this to CV image. And there we go. All right, now we have an error. Okay, we can work with errors. Okay, let's see here. Failed. Warp perspective. All right, CV error. Error. I wonder if it has to do with the fact we have our image size. It might be the fact that, no, it should be a ND array. Let's see. There was an error, an assertion error. Warp perspective. Okay. Might have to be because of this. So let's see here. Fine coefficient should be is fine. I should probably update this code a bit. So this happens to, we'll call this a mat, and this is going to be a matrix, or this is going to be an ND array. This is B mat. This is also going to be ND array. And this is a mat times a mat, and then this happens to be B mat. There we go. All right, and then from here, let's go ahead and let's do our get perspective. This one right here. Get transform. So if we call, let's go ahead and, let's see. We were bringing in two different matrices, these two particularly. And they were both being converted to array. So why don't we do this? If image, okay, yeah, this is going to become, this is beginning to start to look like spaghetti code, because I'm going to be checking in bounds. I'm going to be checking what image type it is, and then when we get to warp, it's going to be checking what the image type is, and then thankfully once we get here, it's done. But it's silly if I'm going to be doing this twice like this, where I'm going to go see if I can figure out what the perspective is. So that means that this right here really should be done somewhere else. So because of the fact, all right, so this really should be in the warp section. So the warp matrix, but it makes sense. But it makes sense to have the warp matrix entering the warp. Let's see here. Actually, the way that so if you look here, the main thing that we need to focus on is this right here, the PB, because PB is that's what we're transforming into. PA is just, if you look at PA is just what the original image is like. So because of that, instead of calling this the warp matrix, we could probably call this the actually, do they have a special name for this? They call it destination rec here. They don't actually give it a name here. Oh, that's not fun. What about right here? Nope. It's just source and dest. Oh, come on. DEST rec. How about we call this the, oh, I know. Why don't we go to GIMP? Let's go here. How does GIMP call it? This is warp transformation. This is cage transformation. And then here we have shear, scale, perspective, 3D transform. Oh, they just call it transform. Actually, maybe that then? How about we call this the transformation array? And in this particular case, all right, our input type. Let's see here. So we end up having this be a... Okay, where does matrix is a list? Okay. So we're making a list of lists here. A list of lists, which happen to contain integers. Or maybe not integers, floats. Yeah, these are floats. Okay. All right. And this happens to be a list of integers. And this also happens to be a list of integers, or floats. Not integers, not integers. No, 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 no. Okay, no, 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 no. I keep wanting to say these are floats. We need the decimal point. We desperately need the decimal point. So no, it needs to be a float. Class float not defined. Get item. Operator cannot contain instances. Oh, I get it. It's because of the... I get it. I get it. In this case, we're zipping them together. We're then appending the matrix together to make a... to make whatever this is supposed to be, matrix. And that will be our A. And then here is our B. And then we do the calculation, which is this. Interesting that it has a lot of complaints. Let's see here. Class float does not define get item. So use the plot operator cannot be used in its instance. I wonder if I can just do this. P1 is a float. And P2 is a float. No, okay. Technically it's a list. Technically it's a list. I'm going to ignore it for now. We'll figure out how to we'll figure out the typing later. Oh yeah, this is supposed to be static. So we'll go ahead and make it a static method for now. All right. Now then. So in this case, we're going to ask for the transformation array. And this can simply be a list. This can be a list of floats. And then from that, let's see. These can have the transformation matrices. That's fine with that. But this will be a... All right. So with that in mind, let's see here. I'm going to go ahead and grab that. This needs to go down into where the pillow is. So here and then from this we can grab that. We'll put that right there. So there's our width and our height. Actually, wait a moment. No. Let's go back. Let's go back. Back. Okay. All right, so we're back here. We're trying to feed this now into our array. So I'm going to go ahead and cut this. I'm going to put it right here. Or better yet, I'm busy figuring things out. Give me a second. We'll put that. We'll grab that. Put that right there. this will be the transformation array. There we go. And then this will be the transformation array. Now then, with that in mind, we can now grab this. Now we want to pillow right here. Yeah, I'm going to have to do this twice, which is not efficient. I wonder... One particular way would be to just actually Okay, well let's just write it for now. We can make it make sense in a bit. All right, so we have our width and our height. So that will calculate out this matrix right here. Part of me feels like I should just pass in PA and these two, PA and PB. PA and PB. That way, I can just do that once, and I can then define, and we'll go ahead and use the original, we'll just call it what it is right now, PA, which is going to be a list of floats. You're now going to be called PB. And then from here, we're going to put in PA, PB, like so. And now that we have both PA and PB, we can find the coefficient for PA and PB, like so. Then that will be our warp matrix. And then for our this one, this will be a little bit more update. So for this case, we'll do PA is equal to, we're going to modify, or we'll call this PA mat. And then this will be an array of PA. And then PB mat, which will be NP array PB. We then want to get our perspective, which would be PA mat and PB mat. And this should be our warp matrix, which would be an ND array, like so. Now let's make sure that get perspective is correct. Yeah, get perspective is just these two right here. And we should probably put the D type down too. So let's go ahead and put those in. Oh, why is this complaining? Oh yeah, the typing's off. This is supposed to be a tuple. And then this will be a float. Let's see here. Is it like that? Yeah, it does. Okay. Let's make sure the typing is all correct. That way it won't complain at us. There we go. And then down here, the typing should be, here it is. These should be also as such. There we go. And then from here, let's get back up to here for this. So what we do is we convert these two into matrices. This should be a D type of np dots flow, or we did float 32, wasn't it? Wasn't that what they were recommending? Yes. Yes, it was. Okay. So yeah, we want to use float 32. So let's make sure that both of these are D type float 32. And then from here, we then perform all of our calculations, and then we return might be referenced before assignments. It's because of the else. It's because of the else statement. How about we do this? We will define this up here, like so. And then that way, we don't need to have the typing here. There we go. And here's the hoping that value error will actually throw a value error. Okay, so this is get image shape. This is image.size. This is get, I think what I'm going to do is copy this code here. And then we'll call this, I know that we can theoretically just get away with image size, but we might want to modify things a bit. We might want to modify things a bit down the road, so it's best to keep things structured like this. All right, let's try this now. All right, then im.bounce. Let's see here. So let's call this A. There it is. Okay, then. And then from here, we should have show image, A, and there we go. Okay, did it warp? Oh my. That's actually very difficult to say. All right, how about this? Let's make the bounce ludicrous. How about we set this to 250? How does it look? And the short answer is it did not work. All right. All right, yeah, it did not work. Okay. Why did it not work? So warp image. Then we return the warp image. This is im bounce. We're returning warp. Whatever happens in warp, we're doing that with our bounce. Actually, I wonder if it might be. So here's PA, PB, PA, PB. It should be working. The bounce. It should be stretching it to high held. That's what it should be doing. Let's see here. So here we're getting the image size. Here's our warp matrix. There's our image. CV warp. Here's our warp image. It's going to be part of the union. There's our image, our warp matrix. So yeah, warp perspective. It looks like everything is correct. Why don't we change the... Let's make this something stupidly large. 2,500. Oh, okay. I think it worked. Okay, yeah, I think it, okay, I think it worked. Okay, why don't we, let's get a full image from our stuff. So, let's see here, we have self dot, compile images. Do I have a list of images? Oh, we should have something called image list. Let's compile that. We'll call this comp. There it is right there. Okay, comp. Now if we show comp, there's our picture right there. There's our guy. He's doing pretty well. He's looking pretty nice. I think the picture looks good. Now let's warp the hell out of it. We'll bounce. So now we're going to bounce comp. And we'll call this wcomp. Let's have him warp 30. There we go. Now let's show wcomp. Now how is this looking? Oh, if you look, the frames have changed all around it. It worked. Okay. It worked. All right, all right. Hey, it's working. We need to probably modify the background a bit because now the background has black bars in it. Look at that. We have black bars everywhere. We don't really want those. Actually, his feet kind of... Actually, I think that's just because of the... I bet if we zoom in enough, we can see his toes. There you go. Yeah, we can see his feet. All right. But hey, that's working. Okay. So warping is working. You can kind of see how I set up the bounce now. This is... Yeah, you can kind of see how I set up bounce. Now we just need to fix the background issue. So, actually, if you think about it, this is a problem not of what we're doing right now. This is a problem of our layering. So let's see here. So yeah, this is a problem of our layering. Let's go to our... Yeah, we're not going to separate. This is CV Animator right here. Yeah, we're not doing that anymore. Let's see. Yeah. See, I have CV framer and then layer. That's... Yeah, we're going to change that. Instead, it's just going to be frame animator and layer animator. And then we'll figure out if we're messing with a particular... If we're messing with pillow or if we're messing with CV. I feel like that it should just be a toggle. People should be able to decide, hey, I want all of this to be processed in pillow. I want all of this to be processed in CV or CV2. So we can easily just say, hey, when you build this class, say what you want to use. Do you want to use CV2 or do you want to use pillow? And then it can figure things out from there. So these are how the things are being compiled. So let's see here. Let's do this first. If you look here, this is where I was creating the background. This was actually kind of a test. Yeah, I was doing tests with this. So let's see here. So I think I can remove that now. And I'm thinking. How about, yeah, we're going to go ahead and delete this anyway. Actually, I'm going to go ahead and grab that real quick. Because ultimately, we would like to have a background at the end. So, how about we do this? BK background. BKGD background color. Background color. It's a tuple. It's a tuple of 3 ints. I missed the P. Okay then. All right, tuple from typing. Now the idea is that we're going to run through all of the images. Now then, we should probably set this to equal to none. So then now if we go if background color, then what we'll do is, let's see here. We should make a file called background color. This will be an ND array. Pretty much we're building this. We're doing this exact same thing right here. It's this. It's that. Yeah, we're putting that together. We are going to put this here. Then what we'll do is, since this is a, oh, come on, don't die on me. Okay, anyway. So this is going to be very easy for color in, okay, maybe it's not going to be that easy. In background color, and this should be, instead of calling this background color, we'll call this background background image. So for that, we'll then simply do this, put that there, and then this needs to just be, we should probably enumerate background color. There we go. And then this would be the index. This will be the color. And then last but not least, we will then composite the image. And in this, we will have self.overlay, overlay images. And we want the background image to be first. So this will be background image. And then we'll want the composite image. Like so. There we go. Okay. So with that in mind, now that we have this set up, it should be, now that we have this set up, we can add in a background whenever we provide a color. So let's go ahead and do that. Let's see here. We were calling this self. Oh, CV animator is not defined. Did you mean CV animators? Yes, I meant CV animators. There we go. Now then, let's go ahead and compile an image. Comp is equal to self.compile images. There we go. Now if we show it, because this has a alpha channel, the background should be completely black. Yes, there we go, perfect. All right. I accidentally loaded up my trash. So there, and then if we, let's check out the shape. And it has the 4, all right, perfect. All right, actually, quick question. Let's load this back up real quick. Are there any artifacting around the layers? There's a couple spots where you can tell that the image has been not very well. There's a lot of imperfections in the image. Yeah, there's a lot of imperfections, but hey. This was drawn a while back. This was supposed to be the Halloween costume right here. I was planning to make a variety of different costumes for my character, so he was going to have, well, again, a variety of different costumes. He had his normal outfit, he had lab coats, he was going to have Christmas outfit, Halloween outfit. I even was thinking about drawing him in a green outfit for like St. Patrick's Day. But yeah, I decided that I should probably update the character first because he doesn't... There's a lot of ways to improve him. For instance, one, his nose. His face is not properly structured. He's lacking the muzzle of a raccoon. So everyone used to think that the nose that he has is like, oh, is that an O mouth? Like, no, it's actually his nose, but it's just poorly, very poorly drawn. So I'm currently fixing that. But I digress. It looks like this all worked correctly. So now with that, what we could do is this right here. So this right here, it should be in the image manipulation file, because that's what we're doing. We're going to manipulate it. Particularly, this is going to be add background. And then from here, it's going to be an image followed by the background color, or background color, which is again that tuple with 3 integers in it. And this is going to return an image. Or this should be image union. There we go. And then from here, so let's see here. Oh, okay. In this case, we have our image. We're going to have to simply get our... this probably should be somewhere else. We'll do that. Get... There it is. Get image shape. Image. Then from here, we'll call it the... image shape, which just happens to be a tuple with 2 integers in it. Oh, all right, fine. We'll go ahead and copy it over here. So image shape. There we go. And then from this is no longer going to be a composite image. This is going to be, we'll call this image. And then here we'll just return composite image, like so. And it looks like there's a function that we're missing, which is overlay images. Okay. Yeah, the overlaying of the images. So technically this should still be in the, this should still be here in the animators, huh? Because we're utilizing the overlay images function. Let's see here. I guess it will be fine. Yeah, I guess it'll be fine. How about we do this? How about we do it? Since I already mentioned that we're going to, so we'll call this the IM, or image manipulator. And then this is going to be the image manipulator. All right. So we're going to import in our image manipulator. Then from here, yeah, because there's overlap here. There's technically overlap between what I'm currently doing here, which is the compiling of images and image manipulation are both kind of the same thing. They're both modifying an image, which is kind of why it's I'm trying to think of a way to separate them, but there's actually kind of not much of a way, huh? This will help out a lot with, for instance, like holding all of the different ways we can modify an image. Okay, why don't we just go ahead and, again, I'm trying to think of ways so that we don't have to, okay, we'll go ahead and add in the union. Overlay images is going to pretty much be part of the union. Compile images. The output is also, technically these are all ND arrays because this is a, but yeah, as I said, we're going to modify this. That's what we're going to do. So, all right, where are the errors? Here are the errors, right here. Oh yeah, we can worry about that later. For now, let's see here. Yeah, the whole thing is about the frame the framer and the layer. The way that we do the image manipulation is either frame by frame or layer by layer. Actually, you know what? Maybe I should... Let's get over to our... Let's get back over here. How did we look at things originally? Okay, then. Oh, I see, I see. Let's get out of that. There we go. Okay. So how were we doing this originally? Oh, yes, I remember. Okay. I remember now. This is where the... I'm going to have to come up with a better way to describe it, because layer... we're using layer already. The first was... Because our original setup, if you look, each of these are individual components of our composite image. So the idea was we do the modification after we composite everything, or we do the modification by each individual component of the frame. And the reason why is because if we go back to our picture, let me show you this one. The idea is that the eyes here are not going to be white at the end. Yeah, the idea is that, let's see here, where's the compile here? Compile. Let's see here. I'm trying to think of a way to show it. Oh, actually, you know what? I can just simply load it up here. All right, open you up with GIMP. All right. So if you look here, this is what our layer looks like. There's our eyes right there. Now what I'm hoping to do is set it up so that I can do a colorize later, and I can change the color to whatever I like. For instance, here you can see it's now blue, or I can make it red, or I can make it black. Would probably be a bad idea, but you get the idea. Oh, actually that would be fun. Maybe I should change the put the screen of the VR headset on a different layer as well, because then I could have an inverse where instead of it being I think I'll do that going forward. I'm going to switch the VR headset over to a blank screen or a colorless screen, so that then I can set the color that I want it to be. That way I can have a white background with black eyes, or I can have a black background with white or red, or whatever color it is. These types. I could have eyes with green, or as I mentioned, I can make it rainbow. The idea though is to modify this component before the compiling of the image, so that when we get to the final step, when we get to here, that will be red instead of what it looks like right now. So, yeah, so because of that, I need to change this, because this is framer and layer. But we're already using the terms frame and layer based off of how the folders are designated. For instance, this is layer, which means that each folder is the different component of the image. For instance, this is all of the eyes. This is all of the tail animation involved. So these are the individual frames of the tail. And then if you go over to frame, we go to the same location. There's fidget. You can see these are actually the individual frames now. So we have 8 frames in fidget. And then this is what changes. This is the tail that changes. If you go to the first one, here are all of the different layers. So in this particular way, tail is the only thing changing among the frames, which is why it's set up the way it is. While in the other one, you could see that it is all... It's the way that these are structured. As you can see, folders are frame by frame, or the folders are the layers of the animations. So we should probably rename this so that it's not confusing. Let's go ahead and copy all of that first. Get out of CV Animator. I'm going to put this right here. Oh, we don't need... I don't think we need any of that right now. Oh, we might need the image manipulator. At least until I figure out what to do. Let's see here. Let's go ahead and import CV2. And we should import tuple as well. Tuple and last but not, what are these? Layer, oh yeah, this is the main function that I have been doing tests with. All right. So let's go ahead and rename these now. So these are the animators. This is the basic abstract class. So for this, instead of calling this CV Animator, this is now going to be composite animators. As in, and let's put down a let's put this down here. So all no, everything or all manipulations are performed on the composite image. And then this one right here. Oh, okay, we don't need you. So let's go ahead and grab this. And the next one here, let's go ahead and do that. As for this one, animator, and what should we call this? Component animator. And in this particular case, this is going to modify the components before composite. Oh, again, this is... I think I'm going to have to think about it, because when I write it down and I think about it, I think, oh, this is this severely limits what we want to do with our code. It really limits what we want. Hey, nothing really. How's it going? Oh. Those, yeah, that's capybara. Yeah. These are capybara. Are they cute? I believe this is an image from Izuzu. If you ever go to Japan and you ever want to go look at capybara, you should head to Izuzu. Because they do this with them. is called the Capybara Onsen. You can only see it during the winter. So you have to go during... I think they start handing out, or they start setting it up for the capybara like this in November, December, January. So you need to go... Oh, actually, I think they might have highlight it right here, huh? Oh, wait. I get... Never mind. 11th to... Okay, yeah, that's correct. So from the November to April, they will have it set up so that the capybara can enjoy onsen with lots of vegetables in there with them. As you can see, the capybara love it. Check them out. And look at all those pumpkins and lemons. And so, yeah. This is Izuzu. If I... Oh, one moment. Let's see here. It's once a day. Oh, my. Yeah. They're very cute, aren't they? I'm trying to... I don't remember exactly where it is. Let's see here. Do we have a... Let's see here. Izu Sobaban Zoo. Yeah, right there. To get to it, you have to pretty much travel from Tokyo. See, there's Tokyo. There's Izu Zoo. There's a train line that you would take. I actually took it, which is why I remember. Let's go with Tokyo Station. Oh, no, we want to take the train. Oh. Anyway, there is a train. This is DuckDuckGo's map. Okay. Well, sadly, I never made it to Izuzu. There's actually another one here, though, that I visited. Let's see here. If you type in zoo... There should actually be a couple zoos around here. Yeah, search zoos in nearby area, right here. Oh, okay, poop on you. all right. Okay, poop on you. But if you look, there are a variety of zoos around here, and they're all quite fun to visit. I visited a different one in Izu, so I believe the one I visited is somewhere around here. But if you go closer to Ito, you'll find the Izu Zoo, which is the one that has the capybara in it. Hey, Zagger, how's it going? We're currently building an animator. The idea is to make it easier to build the videos for my avatar. If you notice my character, he can bounce around. I can have him jump. He can headbang. It requires to build a lot of videos. And I figured it would be better to write code to do it. Because my old code was, it was kind of very unoptimized. I think the worst part about it was the code it went through like 4 different steps. I ended up having it compile videos using CV2, and then it would do all of the transformations using Pillow, and then after that, it would then outsource the processing to a program called AVI Demux to do a lot of other processing, like shrinking it and other modifications. So I'm actually hoping to do it all in Python this time. Yes, I am doing it by hand. I've tried to set it up to, let's see here. I actually tried to do this with a clanker. because I'm trying to have fun learning. The whole purpose of doing this is to learn. So I thought what would be kind of fun is to see how a clanker would do it, and if I could potentially improve on it after doing that. Come to find out, it doesn't know how... call me crazy, but it just doesn't... A clanker just doesn't know what it's doing sometimes. So for instance, if we check out... If we check out the code here, this is Zig code right here. I was hoping to... The original idea, the original plan was to take my images that I split up for making the different animations, and instead of piping it into an MP4 format, it was going to send it straight to a video buffer so that I could kind of build the animation on the fly. That way I could eliminate a large chunk of overhead that is sadly needed for my character to be able to do these different animations. So I thought I was originally going to do it in Python, which is what the original code was set up to do. If you go into my Python code, right here, here's the old code. If you go to Animator, you can see here it's set up to actively generate the animation. I'll get the sequencer, I'll set up the sequencer for the type of character it's going to be, I'll set that to generate the animations, and then it should start running. And then it would end up using... originally it was going to output it as a... yeah, this is where it got got wonky, because originally I was going to output it as a... in an IM window, something like that. They would refresh every 60 frames per second. But because Python is so slow, it effectively destroyed any potential of it working. So instead, I thought I would move over to Zig, which is a C++ program. So if you look at Zig, Zig is it's a updated C++. The idea for Zig is that it will, if eventually it gets good enough, it will be a replacement. Rust was supposed to be a replacement of C++, but yeah, I'm not using Rust. No thanks. Apparently Odin is supposed to be fun. I haven't checked out Odin yet. I really need to. But yeah, if you look here at the code, you can see that it imports its libraries. It then sets up an animation frame. Oh. Then if you continue... Yeah, they're very anti-clanker. You're very right. Which is probably... it's quite fun. I started messing with Zig before they came out as being very anti-clanker. And I could kind of see why, because on the surface, this looks pretty normal. But then as you start going deeper, you're like, why is it doing this? For instance, like here, let's see here. Where's a nice example? This entire for loop right here. Like, why is it doing this with the for loop? This entire thing. How many tabs? 1, 2, 3, 4, 5. 5 tabs. Okay. So yeah, this is 5 tabs in. If I submitted this code to anywhere, they would probably kick me out and say, go learn proper programming, you. Like, why is it so... This is pretty bad. You think it looks good, but it actually looks horrible. When you start digging in, it's horrible. It's horrible. And then here's their main function, and you're sitting there thinking, why is all of this in the main function when it should be separated out somewhere else? Like, this is bad. I was so disappointed when I had the clanker set this up, so now I'm just trying to figure it out myself. So I figured the first thing I'll do is I'll update my Python code so that I can generate videos. And then once I have it all sorted and figured out, then I can move over to Zig. And kind of, because the idea is that I need to figure out the structure of everything before I start trying to learn a new programming language and do it there. So that's the general idea. Hence why we're currently in Python. And currently being mauled by logic because and what model did I use and what harness? So okay then. So the model that I used was, I used two different models. The first model was OpenAI. I think it was, when I wrote that code last time, it was OpenAI 4.5. I ended up using a software called po.com. So I can show you that real quick. po.com. See, here's po.com. It is a system that you can use for using the different models. I use this because a lot of AI models are banned in Hong Kong. And yeah, because it's banned in Hong Kong, I have to use a roundabout way to access it. And Po is what allows me to access it. I ended up using 4.5 before all of these new ones showed up. And then after that, the second time I used it, I ended up, because Po changed their, how they, Po's now token based. Originally it was a subscription. So you could subscribe and then use it as much as you like for a given amount of time. It did have token. It was still token based, but they were very liberal with their tokens. They've completely removed that. Now it's all just purely token based. So the next one I ended up using was, and you can say that, you can call me, you can, yeah, I'll put a derp face up because this is very derpy. I deserve it. I ended up using Copilot. So if you go here, you can then ask it to do something. Write in Zig a program that will take a folder of images, compile the images into a single frame, and output to a video buffer. You know, I can type a bunch of crap here, and then from there it will then run and then generate the code for you. In this case, it wants me to log it because I'm not logged in, and I'm not going to. Oh, can it generate? Oh yeah, it can. All right. Well, why don't we let it run for now? Maybe I'll copy this code if it makes any sense. It already looks like it's not making sense. Nope, it's not making sense. It completely forgot everything. Where's the video buffer? Pass to FFmpeg. All right. Oh. Yeah, okay, you get the idea. Yeah. I was using a chat interface. I did think about setting up a model from Hugging Face. So I did think about setting up a model from Hugging Face. Let's see here. They should have code now. Where are you? Maybe I need to type in code. All right. I'll have to look for these later. But yeah, I was thinking of doing this. You would recommend Cursor with Composer 2.5. Yeah. I heard that Cursor is actually very, very useful. And so I wish I could, but I sadly don't have the monies. If I had some money, I would. If I had some money to go to Cursor, I would. Actually, is Cursor current? Let's see here. Do they have a free trial? Hey, cursor. I could request a demo. Oh, they have a free one. Oh, okay. Oh, that's new. I don't remember that. No credit card required, limited agent requests, limited tab completions. I'll have to try this out then. Because I remember they originally didn't... Okay, I don't remember if they had it or not. I just know that whenever I see people talking online, they go, oh, I'm using Cursor. I have a subscription for X amount of years. And then they start talking about the costs and everything. And I'm like, yeah, I'm dirt poor. If I had that kind of money, then yeah, I would not be eating pasta every day. All right, let's see here. Yeah, I'll check it out. Thanks for the recommendation. Yeah, I'll check it out. Okay, I have a feeling that yeah, I have a feeling that for my program here, because I want to do both. I want it all. I want to be able to do a modification based off of each component, and I want to do the modification at the very end, which is the on the composite image. I want to change the color of the eyes, and then I want to warp the final thing. So I see. Yeah, I agree. Yeah, I think it'll be much easier with a proper system, because the chat interfaces, they really suck. They really do. All right, let's see. Okay, we should probably... I'm going to go ahead and do that right now, just to get rid of it. For here, where's that error coming from? It claims we have two errors. Here. Oh yeah, because of if background. So yeah, this is the if background. So in other words, if we get to the very end of the compiling of the images. So technically, I think that we can still keep add background separate. This does not need to be hidden. Actually, that's good. It's actually good right there. We can keep this here. I have the image file. Instead of add background, generate background. And then from here, all we have to do is put in image size, which will simply be a tuple that will be an int and an int. That means we don't have to run this anymore. We can put our image, I call it shape. All right, let's go ahead and put this here. There we go. This needs to be image. We'll change this to shape because they do mean different things. And then from there, we can simply generate our array. There we go. And then from that, what we can then do is, if we have a background, we can then generate it. Then from here, we can grab this is compile images. And in this case, the compiling of the images should be fine. I'm busy looking at how we're doing our... because the compile images, we're taking this, we're going to... ah, here it is, shape. So yeah, that we need to change that. All right then. I don't think we need to do a composite image now. What I think, well, we do, okay, we do need composite image. We do need composite image. So let's see here. We do need composite image. I'm busy thinking. Because what I'm thinking is that I can just probably copy and paste the first image in our sequence into here. That way I don't have to call the shape. I don't want to double overlay. I can think of one way to do this. However, we'll be doing an if statement over and over and over. Composite, or let's see here. The composite image will be equal to image. Continue. And then, all right, I don't think we really need the else there, because it's going to just get skipped when we have a 0. Let's see here. Composite image is going to be an ND array. Oops. np.nd array. We should probably put, actually, instead, let's put the typing outside. We'll put the typing outside and aliquot that so that it has, at least the thing has, we'll make it an empty array. There we go. Okay. There we go. All right. Is looking for, isn't it? Yep, it's looking for the shape. Is this okay code for Python? I personally feel like it is, because we're going to there's forever going to be a 0. Like, this is never not going to run. Maybe let's see here. How about we do this? Instead of enumerate, because I don't want to do the if statement over and over. There we go. If the length of image list is greater than 1, then we will grab this. We'll grab the first image in the list, and then we will proceed to then composite all of it together, like so. We don't need that anymore. Else, we're really just going to, yeah, we're really just going to, actually, I think that's fine like that. Yeah, I think that's fine like that. Because the idea is that we're going to put these together like so. And then from here, we can then, let's see here. Let's see. Actually, we do need the else here. Else composite image is going to be equal to image. Image list. There we go. And then from that, we'll then do a generate background. In this case, I'm busy thinking. Because the way that the generate background works is we're looking for the image shape and the background color. We already know what the background color is, so we already know what the background color is. So this will be the background image, which will happen to be I think this should be an image union. Because it's going to be either or. And then from here, we'll then simply do composite image is equal to overlay images. And from here, we'll want because this is a background image, we're going to put it on top. We want the background image to be first, followed by the composite image. And then from here, we can then output it like so. So image shape is the last thing we need to think about. I spent a few brain cells trying to figure out a way to get rid of figuring out the I spent a few I spent a few brain cells trying to figure out how to get rid of image shape, only to have to get it back in. Let's see here. We're running compile images. Where are we running compile images? Actually, we're just running it here. So this will be the first time we call for the sizes. Yeah, let's get rid of that. I was thinking of separating them out, but ultimately we cannot do that. I don't think we need the abstract base class. We do need the constants. Right now, let's just put this as an animator. Okay. We'll focus on, once we get to a point where we have to start separating it out, we will. So yeah, we still need to figure out image shape. And, oh, here's generate background. Yeah, we're not doing that anymore. We're just going to generate our background, our image background, and then send it forward. This is static. All right. So yeah, last but not least is image shape. I guess what we could do is we could call for that. Yeah, this is yeah, this is we're going to okay then. Yeah, this is, we might end up, we'll have to be very cautious with this. Because if you look here, when I was setting this up, this old code, the amount of variables we were tracking kind of ballooned like you would not believe. You could see here, this was the layer components. So we had image layer, that we would then have the different components like the name, the path, if it was visible or not, if we're colorizing it, how much we're going to warp it, the layer, and then the destination, as in where it would fit on said image. And I wonder if, because the idea was that right now it's all programmed so that the images are all the same size. Why do I have a feeling I'm going to have to copy this over and just start trying to detangle this mess? Let's see, where was the original mess? Here. So this is supposed to be an image.image. Let's go ahead and import an image. Oh. Come on, Pillow. We just want the image. And then we'll also need to import image ops. Yeah, this was the original code. Because the idea was that I set it up so that each individual frame would contain the different components. So maybe I should just run this code real quick. Why don't we do that? All right then, so here's Framer. We'll call this B, or why don't we call this FR? Framer was looking for a name. So it's looking for, yeah, the main thing we needed was a name. So we'll call this stand. Then as you can see here, I have a whole lot of, like the bit depth, the image size, which this was all pretty, this was all standard. These would eventually have gone away when I was programming. And then here you can see background color, image mode. So let's go ahead and set this to FR. Now FR dot, let's see here, image file locations right here. So add layers or add layer. Let's go down to add layers. Here it is. So in this case, we look for the locations. We can give the names of the lists, and then we can give a layer list. Again, this was all barmy setup, because the idea was I would just have 3 frames, and then I would be able to tell it, oh, these 3 frames will be repeated 7, 8, 9, 10 times. So then it will just try and put into memory those 3 frames, and then it will output the whatever we wanted. So, let's go ahead and do that. Let's add in some layers right now. Checking out my old code. So this was the image locations. It happens to be a union of a path with a list of paths. All right. Oh, I get it. I get it. I know what this is. Maybe we should just do add layer. I think this actually, I think add layers is going to run add layer, isn't it? Yeah, it is going. It's going to add it, do it at the very end. Image locations, a directory path or list of image paths. So this is a union between these two. Got it. So why don't we just give it a path? All right then. So let's go with. Actually, if you think about it, I should already have one down here. Yeah, here, right here. Since we're just going to try and build a frame, let's just go to a single. Oh, yeah, since we're trying to build a frame, let's just go to one. So hoodie, happy, fidget, or I think that's it. There we go. That. String attribute has no. Oh yeah, they want paths. Make this a path. There we go. So fr. There we go. Now if I do fr.compile, cannot interrupt 166 as a data type. Oh, cannot interpret. I wonder if there's something I missed. Again, this is why I'm trying to rewrite this now. Reorder layers. Get layer names. How about we do that? How about we do that? Let's go with fr.get layer names. It has no names. Okay. So fr.components. And that's empty too. Did I... Is this even a real folder? Let's see here. Hoodie, happy. So layer sample, hoodie, happy. I might be that. Fidget. Let's go one more below. Fidget. Has no length. Okay then. Now then, fr.components. Still empty. How about we do get layer names? All right, I'm going to do get layer. Or yeah, this is why I am rewriting it. There we go. So now we have the components set up. Let's see. So our fr.get name or get layer names. It's just called fidget. Okay. Let's see here. Where's get layers? Or here it is, add layers. So if layer list is none, then we will we'll do this. All right. Okay, yeah, I need to... Yeah, okay. It is a bit borked. It is a bit borked. I don't think I can salvage much of this. It will work if I go to the very end. So I know it still works, but how it works, I will have to spend some time to try and figure that out. And I feel like I've been coding for 3.5 hours. I should probably... I'm going to call it... I'm going to call it for now, and I'll continue figuring this out. We might end up having to set up the animator. We're going to have to really figure things out at the very end. Like, how exactly do I want it set up? Am I going to have to go back and start modifying the framer code? Or should we just kind of forego that and try and just keep it as simple as possible? Where all of the frames, because right now, if you look, all of the frames are the exact same size. If you look here, the VRIs it has the exact same dimensions if we load it up. See, VRIs has the exact same dimension as the body, right here. See, they're exact same dimensions, and they just overlay on top of each other. This is why this is to hopefully make it quick and simple. That's the general idea. But in order to save space, maybe I would want to zoom in, and this would be the only bit that's kept, and then I just define where it's located. But again, that adds a lot of complexity, which is what the originally Framer was trying to accomplish. The idea was to frame every single layer. Let's see here. Here's old sequencer. Yeah, the whole idea of the sequencer was to generate everything together. Load images to sequence. Load components directory. And then here we had the directory path. We then had the warp presets. Yeah. Okay, I'm gonna figure this out. I'll go back through the code, try and figure out what's going on, see what I can figure out, and from there I will we'll see what we can salvage. Yeah. Thanks, Zacher. I will definitely have to go through this and see what we need to do, but for now I'm gonna hop off. Oh, I have my alarm system is now up and moving. My alarm system is up and moving. So, okay, I'm holding on to the alarm system right now. But yeah, we'll figure more out next time. Until then, everyone have a good one. And have fun programming. Oh, will you stop touching things? Oh, yeah. Come on, stop touching things. Anyway, have a good one.